In this video, we'll explore vSphere 6 virtual machine concepts. And the VMware Certified Associate exam is still focused on vSphere 6, so we're not really going to get into any specifics when it comes to vSphere 6.5 in this or any other lesson in this course. So a virtual machine is very similar to a physical machine in many ways. Right? A virtual machine has an operating system installed on it, and that operating system needs access to CPU, to memory, network interface cards, and storage. And the guest operating system of our virtual machine has no idea that it's running within a VM. So the goal here is basically to trick the guest operating system into thinking that it has real hardware. So let's assume in this scenario that our guest operating system is Windows. And we see in the little purple box here, we've got a Windows virtual machine. Windows needs CPU and memory in order to execute. So we'll allocate a certain amount of those resources to this virtual machine. And Windows also needs a C drive for us to install the operating system on and space to store files. So we will present virtual disks to it. And our virtual machine also needs to transmit traffic on the network. And in order to do that, Windows needs to see a network interface card. So we'll install some network interface card drivers in Windows and present an adapter to the guest operating system. And as far as Windows or whatever guest operating system we happen to be using is, as far as the guest OS is concerned, this virtual hardware seems exactly the same as physical hardware. Now, one of the resources that we're going to present to our virtual machines is CPU and memory. So let's assume in this scenario, our Windows virtual machine has been created with 2 virtual CPUs and has been allocated 8 gigabytes of memory. What that essentially means is that this virtual machine is going to be able to utilize the CPU resources of 2 physical processor cores, or pCPU, physical CPUs. That's all we're saying. So if we create a virtual machine with 2 virtual CPUs, we're not guaranteeing it full reign over those physical processors. There may be other virtual machines that it's sharing those processors with. What we're saying when we give a virtual machine 2 virtual CPUs is we're saying you're allowed to use 2 physical processor cores if they're available. They might not be available. They might be used by other virtual machines. So we're not making any guarantees here. And the same concept goes with memory. We may create a Windows VM and give it 8 gigs of memory, and that's what Windows will see. Windows will see 2 processors and 8 gigs of memory. But again, we're not guaranteeing this VM 8 gigs of memory. And by the way, the VM is only going to take up the physical memory that it actually needs. Right? So if this particular VM is only using 4 gigs of memory at the moment, that's all that it'll take up on the ESXi host. This is referred to as thin provisioning of memory. And our virtual disks operate in a similar manner. Right? Again, we're going to trick our guest operating system. So just like memory and CPU, the virtual machine doesn't really have any actual hardware. Right? It's accessing a shared resource. And in this case, that resource is called a data store. Windows needs to see storage hardware, so we'll trick Windows into thinking it has a SCSI controller. We'll provide drivers for a virtual SCSI controller. So when Windows needs to read and write data, it generates SCSI commands, and those SCSI commands are set to the virtual SCSI controller, which is basically fake hardware. Right? And when those SCSI commands arrive at the virtual SCSI controller, it's the job of our ESXi host to redirect those commands towards the appropriate storage location. That's how we achieve storage virtualization. And this is an important slide to understand, because if you really understand this slide, you kind of get the whole concept of virtualization. This is a virtual machine that believes it has disks, it believes it has memory, it believes it has CPU. The guest operating system doesn't know that in reality, all of those resources are actually shared resources that are used by many other virtual machines. And that's the whole point of what we see here with the hypervisor and the layer of abstraction. Decoupling those resources from the virtual machine gives us flexibility. It means that we can take this virtual machine's files and move them to some other data store. And if we choose to do that, now what happens as a side effect is the virtual machine does not know the difference, right? Windows does not know the difference. If I take this virtual machine's files and I put them on some other data store up here, then the next time a SCSI command comes out, the hypervisor will be aware of that and will direct it towards the appropriate storage location. But as far as the VM can tell, nothing has changed, right? It's still got its virtual SCSI controller, and that's how the storage traffic is still getting from point A to point B. So from Windows perspective, nothing changes, even if I relocate the files that make up that virtual machine. So the whole objective here is to trick the guest operating system into thinking it has real hardware when in reality it truly doesn't, and giving us this layer of abstraction in the middle to allow us some managerial capabilities. And the concept is very similar with networking. So just like CPU and memory and storage, the VM doesn't have any dedicated physical hardware. It's going to access a shared resource. And in this case, the shared resource that's going to be utilized is the physical adapters of the ESXi host. And here we see a virtual switch with some physical adapters. So when you have a bunch of VMs running on an ESXi host, that host might have some Ethernet ports on it. That's what these are. That's what my physical adapters are. But this is still a Windows virtual machine, and if Windows is going to send traffic on the network, then Windows needs to see a network interface card. So that's part one of this equation, is to fool Windows into thinking it's got a physical network interface card. So we'll present a virtual NIC to this guest operating system. And when the virtual machine sends traffic out to the network, the guest operating system is going to send that traffic to the virtual NIC. And from there, the traffic will flow out of the VM and be relayed to the virtual switch that this VM is associated with. And the virtual switch is actually assigned VM NICs, or physical adapters, so that if necessary, that traffic can be switched out to the physical network to maybe some destination physical server or something along those lines. And then finally, we can also connect USB devices. We can connect ISO images to our virtual machines. So we have a wide variety of different storage and other sorts of hardware that we can integrate with this VM. Right? Okay, so in review, we learned that virtual machines are presented virtual hardware, and the guest operating system is essentially being tricked by this virtual hardware. So the guest operating system has no idea that it's actually running as a virtual machine. Virtual hardware version 11 was the current version with vSphere 6. We also learned a little bit about virtual disks. Now, as we move throughout the course, we'll dig a little bit deeper on how storage actually works, and we'll learn about the differences between thin and thick provision disks. And we'll have much more on that if you ever take the vSphere 6 Foundations course. That should be coming out shortly. We'll have a lot more detailed information in there about virtual disk types. And then finally, a virtual NIC is also provided to our virtual machines as well. There's a specific type of virtual NIC called the VMXNet 3 that's recommended in most cases. But regardless of the type of virtual NIC that you use, the concept is still the same, right? We're presenting a fake virtual network interface card to our